Oh yeah! Roadhouse! Even played on a Sony. Hey guys, this is Cole from Regal Metalworks. Hey, today we're going to be doing some machining here of these adapter plates. We're going to do the back side. Yesterday I spent about 4 hours getting the cam good to roll. I got one of them done in 5 hours, which is ridiculous. But I got it all good and ready to go, so I'm going to get these two here, and then here's the mirror. I have another one. I'm waiting for material to come. I haven't done the cam for that yet, but it's basically the same way I did this. I just basically copied it and then just reselected the points. So I'm going to go over that right here because I had some issues with some of the cam, and maybe I could help some people out here in Fusion 360. So let's go take a look at that before we get the day going. Everybody. So we got this part that we machined this side already. We need to flip it over and we need to machine this part. Now I made this part, two of these for a race team back in March of 2017. And you know, if any of you guys have done any machining and you made a part, you don't remember how you really made it. I mean, I document things, I take pictures, I post them on social media, it gets uploaded to my Google Photos account, and I usually go back there, and now I got the vlog running, and sometimes I'll go back and reference it, and I'll go, oh, okay, that's how I clamped it, that's how I held it. And it really helps. But for this one, I only had a picture, and it was kind of deceiving because I had it on a pallet, but that's not how I finished it. And I'll explain in a little bit more detail here. So basically, when you do the backside of a part, in other words, you machined all this material away, and you just have this little bit of material that you were work holding it with. So you usually would just, you know, put it in a vise or a set of soft jaws or something, just plane the black off and you'd be done. Now here we have pockets. This would be considered a pocket. So these bosses need to be there. They're offset bosses for the brake caliper. So it was a little challenge for the first time I did it because it was the first time ever I had to machine something on the backside other than just machining it, planing it off. So I had, normally would do, like, if I was going to proceed to do this initially is, all right, we're just going to do a 2D adaptive and we're going to clear all this material out. But because we already did a 2D adaptive on the other side, a 2D adaptive on this side, I couldn't quite do because I needed to work hold this. So in order to work hold this, I decided, and it took me some time yesterday figuring out how I did it, is I actually bolted this down to a pallet, right? So I have 4 holes that are already pre-drilled. Now, these holes here, I can't machine, right? Because they're already there. I want to machine everything else around it away. So I figured I would use these 2 holes here to bolt down, and then I just want to machine everything else away. So let me see if I can find... Oh, I don't have it here. Actually, this was a little challenging. I actually had to make save it as a different version. I don't know if you guys have used this. I use multiple computers on Fusion, and sometimes when you use one and it updates on the cloud, because this is all cloud-based, and then you open up another computer, sometimes it's not there, sometimes the changes didn't update, sometimes it just, you know, blows away whatever you have. Now on this computer here, this is my office workstation, I never shut it down, it's always up, Fusion's always running, so sometimes I don't remember to click save, right, and it doesn't overwrite, and then I'll be at home and I'll use my laptop and I'll open the file and I'll be like, where's all my changes I made? Oh no. And then you can go back here and see these little V, this is your version. If you click this, this will bring up all the versions, and you can actually go back to a previous version that you had saved and push it forward so that you can then open it, or you could just open it. For some reason though, on this workstation, it struggles. It just times out and just sits there, you know, like, I don't know what you want me to do. I don't know, whatever. So we'll get back to machining this. Okay, so the problem I was having is the G-code that I had generated for this. You can see here it doesn't touch these islands. That's exactly what I needed. But when I made a change to a retract height on this and regenerated the code, it then mowed through my islands. I was like, well, how am I supposed to, that's where my bolts are going to be. Why is it doing that? And I couldn't figure out how to tell it not to do that. So if we go into edit here, there's no, like on some of the 3D options, you could say don't touch this area, but on a 3D adaptive clearing, it doesn't give you that option. So what I had to do was I had to go in and tell it and give it a machine boundary here. Stock contours these two surfaces, right? And that was, you could also do a machine boundary, stay within the boundary, but this seemed to work for me. And what it did is it allowed to machine these two areas, right? So you're like, well, I don't need that done, but here's what you have to do then. So you come through here, and then I actually did this. I used these two holes first to bolt down. Then I went through and I cleared that off with an adapter. Then I faced it to make it a nice finish. And then I used it to bolt down. So now when I went into my adaptive, you see it's not touching these areas. And how I did that is by using rest machine from previous op. So it already knows, because it's 3D machining, that you clean this off. So it doesn't need to touch that. It doesn't need to go over and remachine it. That's some of the great things about 3D machining, is it already, if you do use rest machining, it will know that you already did that, and it will save you. So originally I was just going to bolt these down and I was going to run a fly cutter across it after the fact, but I was like, oh, I can kill two birds with one stone if I do it this way. So now I'm able to, first I clamp down here, clean these off, and then I go back here and move my bolts over to here, and then I do the rest of this machining here, this adaptive, okay? And this went and cleaned everything off here. Now we have the next problem, which you may see, is it's wanting to clean down all this area because it thinks it still has all this stock, but it's not there, right? I'm not sure how to really fix that, and this is a, if you look at the time, machining time, you'll see it's 22 minutes. You don't want to let that cut air. You don't want to have to stop it and then, you know, run a different operation. I want to run this all together. So what I did is I saved this as its own NC file, its own G code right here, okay? And then I went ahead and opened it in NC Viewer, available online. And the reason why you'd want to use this is this actually gives you a graphical interface. So if you look here, here's all the machining that it's doing, okay? So I know that this very second machine mark here, that's the next layer down. That means it machined everything off the top. I don't need that. So if I go and I click on this point right here, it brings me to this line right here, 5125. So that's the end point right in here, where it's saying it's going to drop down here and start. So what you're able to do is go in 5125 or somewhere in that vicinity into your G code here. And now I have already done this. So 5125, I highlighted it and selected out all the rest of the G code except for the ending M5 and M9, which turns off your spindle, turns off your coolant. And I went ahead and just deleted it out, resaved the file. So now I have that file saved without the rest of this machining. It's a nice little workaround when you can't get the software to do what you need it to do. So I was able to like just blow out that G code there. So then I was able to machine that successfully. And then I went back and I ran my contours here to pull this island out. And then I did my scallop like I did for this side with a 1/4 inch end mill. I could really use a 3/8 inch end mill. It would save some time, but it leaves a cool pattern here. So this basically is taking off the last 20 thou that I left there with the shear hog. A contour. Now, maybe some of you guys can help me with this. So, and it's probably the way that I drew this part. As you can see, it's like two separate entities together. When I did the contour around the outside of this on this side, it avoided this area and this area. As you can see, it's two pieces. I could not get it to go the whole ways around it. It would not do it. I know I thought I maybe tried, but this was over a year ago. You know, you could project this image down and then just trace the line, whatever. But I didn't seem to, I don't know if that worked or not. But the problem is, I needed to clean up this area, so I was able to clean up this area. It's not the best way to do it because you do see the tie-in points, and you'll see it when I show it out here a little bit later.
but it's a completely usable part. It doesn't look aesthetically non-pleasing, but if you're going to sell these parts in like a production environment, like I'm going to put them on my website and sell, you'd want to fix this. And that's where it comes down to the point where it may take me an hour or two to redraw this, redo this, whatnot. It's not worth my time. I'm only making 6 of these. I need to get them done and get them out the door and get paid. If I spend any more time on this, I already spent 5 hours yesterday figuring out how to machine this backside and doing it correctly. You know, I don't recoup that cost time. So if it does if you're going to make hundreds of these and sell these. But if you're a job shop and you're just making a part to get it out the door, which is what I did last year, you know, and then they came back and said, oh, we got 3 more people that want these, you know, can you make them again? I'm like, sure, you know, no problem. You know, and then you have to go back and revisit it. Now, if this was a product I was putting on my website, like I said, you know, you'd want to straighten this out. But this works. It's down and dirty way to get it done. And then I finish my chamfers around there and a chamfer around the outside of this. And then we're ready to machine at this point. So this all works. I already have this G-code all loaded up. So we're going to go out and start to machine this now. All right. All right, so we're going to go ahead and mount this up in the machine this little holder here. This would be like a pallet that's specific to this. So you can see you lay that down and you would bolt it down and you'd be able to machine it once you set your work offset with that. So I'm going to go ahead. When I drilled these, when I machined the other side, I made sure to drill through so they could use these bolt holes. But the bit I have was pretty dull, and you can see it just kind of pushed through there. So I have to take a deburr tool and deburr that. You just take a deburr tool, like a Noga deburr tool, and you just deburr that. Knocks that edge down. These things are great. Any fabricator should have a plethora of these. So basically just knock that burr down. Now we'll have no burr there to bolt it down with. So we're just going to go ahead, we're going to machine these 2 holes here first, because that's our final bosses that stick up. We're going to machine that down first, like I showed you in the cam, and then it'll be bolted down here, and then we'll move the bolts over to here, and then we'll machine the rest of this away. All right, we got these two bosses. These holes will be the bosses here that we're going to machine first. We're going to machine out so that they're done. Okay, so we're just going to bolt these down here so that we can machine them out, and then we'll move the bolts over to here, and then we'll machine the rest of this away. Okay, now I got to center this piece on here. I'm using my hammer to center this piece because these bolt holes won't square this to this piece here. Normally when you put this into your vise, you tram your vise in. So now I got to tram in each part to my pallet, which is kind of a pain, but it's something that you have to do if you want to make a square part, especially because you're machining the back side. You have to make sure that it lines up with the front side, and if you don't, it's going to be mismatched. So you just need to get it as close as you possibly can. Let's see, we're way out here. It's kind of the same way you would tram in a vise. Just go back and forth. So if we just tap it a little bit. Just going to do anything now. I'll go the other way. We're into thou, which is, if we tighten this down, it might pull us back in a little closer. Yeah. So we're thou there, and that should pull us in a thou on the other side. Yeah, within a thou. I would like to be a little closer, but this isn't a machined edge. It's just from how it was made in the mill, from the foundry. So that's not going to be perfect. So if you're within a thou, it's going to be close enough. We're not building space rocket parts here.
Check, tighten this. So now I'm going to use my probe to dial it in. You could use the hammer and find dead center, but I find the probe is a lot easier and a lot more repeatable. Hammer's great for what it is though. So we're using the ITTP probe made by Cliff out of New Zealand in his small workshop. It's full of awesome equipment. Here's a card to a video that I had done a quick review of it. But this little thing is a gem. It is virtually indestructible. I mean, this thing it moves, like, and it doesn't break. Like the hammer, if you look at it wrong, it just wants to snap on you, and that's a $40 tip. That's expensive. So having a couple tips in stock for that, you know, you can wrap up $80, $100 just so you have a spare to finish a job. This, you pay for it up front, but then you don't have to pay for it on the back end, and 9 times out of 10, you just need to get stuff done. It might be a Saturday or a Sunday. I don't have a tip, I broke it, now I gotta go old school, use Ed Finder or whatever. And if you're machining something like this, where you need it to be pretty accurate, so that you have a nice looking finished part, I can't give high enough praise to this Hallmark ITTP, which is his probe that he designed, engineered in-house, tested for over a year, and has available now. And it's all made on Tormach machines, believe it or not. So we're going to go ahead and probe this guy. Probe. We got to find work center. Okay, there we go. We got our X and Y marked for center. So what I like to do now, we got to set our Z, is I'll just raise this up to clear everything, and I'll just go to our X, Y, 0, and now we're going to set our Z. You can get this down a little lower so you don't have to let it work real slow. That was at 10 inches per minute, so it's pretty slow. You can run it higher, 40. I don't know, it might be harder on the motor stopping, maybe it won't be as accurate, but when it touches off and like does the ball screw, backlash and come back in, it's still at the same speed. So honestly, I think it's fine, because that takes a little while. So there we go. We're ready to start machining now. So to start machining here, we just go into our file. I actually have this, they have for the new version of PathPilot version 2, they have a Wi-Fi dongle that you could buy and plug in. And that is a great time saver, because I was having to grab my USB here and run it back in to make a change and come back and plug it in. Now I just walk into the office, make my changes, and just drop it right into the drive here. So we're doing the brake adapter plate. We're doing second op, which is the back side. So we got first op is to clear the bolt holes, and then we got the 3D adaptive clear, and then the third op, which is third op after adaptive clear. That's probably just my chamfer. I don't know why I didn't put chamfer in, but sometimes it's helpful. I've found that the more notes you make later down the road, it's easier to figure out what the heck was I doing, what was I thinking, because sometimes, you know, you just don't know what the heck you were thinking a year ago. And Fusion 360 is awesome, but it changes every month, and things change in it, and what may have worked a year ago works differently now, and you might be pulling your hair out. I think that was some of the issues I was having yesterday, trying to use the old G code that it had generated was saying it was no longer valid, even though it worked perfectly fine. So I was able to get it to work, but it took me some time. And that's a setback, and it kind of stinks because that's time that I'm never going to recoup. And this job is like a one-time job or a two-time job, and it pays, and that's it, and you move on. So you need to get it banged out as quick as possible. But we're going to go ahead and start machining it. I'm going to stop yapping. All right, there's the first op. We're gonna hit cycle start. It's gonna ask me, tell me to put in the shear hog. That's this guy here, 3/4 inch. I have to put the camera down because I only have 2 arms, not 3. Plops that in there. Get this set up ready to roll. Get our coolant on. All right, we're just gonna hit cycle start here. It should start going. So we're just clearing off where we're going to move the bolts. This is what we're doing right now. Because we have to, where the bolts are currently, we have to get rid of that area. Now we're calling for a tool change. I'm going to go to a 3/8 inch end mill. That's what it's telling me right here. Insert tool 33. It's a 3/8 inch 3 flute. We're going to hit cycle start on that. This is just clearing the floor, so this is the finished op. So that boss, the plateau, as you would call it, that is going to be the finished result on that. So once I move my bolts to those positions, we won't have to worry about going back and refinishing that. I thought I raised that up. That's the one thing you got to worry about when you're machining with bolts as hold down, is that you have enough of clearance for your tool. I thought I moved it up a 1/2 inch, but maybe I didn't. Or maybe I did and I never saved the G code and pushed it over, which is probably more probable. So I'll do that before I make the rest of them. It's a good way to break except on your end mill, but I checked them out yesterday and it looked pretty good. Yep. So now what we got to do is we got to move the bolts, but instead of moving these bolts, I'm just going to put 2 new bolts in so this piece doesn't move, and then take these 2 bolts out. You don't need to watch that. It's boring. Alright, so we're going to go ahead and adapter clear that with the shear hog. So one of the things I'm not crazy about is that little bit of floor that's left. And you'll see it's more prevalent over here. But if I took a deeper cut, I don't think it would because of the floor. So that's actually going to the floor. So that could be about a 20 thou left because I'm leaving 20 thou on the floor to come back and clean up. that all adaptive cleared. We got the floor that needs to be taken down another 20 thou. And then we need to do the profile around here and clean up this. This is what I was talking about, this little bit of push out here. I couldn't run the whole ways around because the ball sits on both sides, and the way I drew it as two bodies, it didn't link it together. And I'm sure if I redrew it as one body, it would probably allow me to do one pass around, which, you know, if I was doing a production run of this, I would probably do. So we're going to do the last and I think final up. Yep. So you can see that. Yeah, that's what that guy is here. We'll put that on ISO view. It's a little easier to see. So that finishes the rest of the op, and then this part is done. There we go. There's the final part. I still actually, I think I have to tap these two holes because the caliper bolts to this and then this bolts to the carrier. GoPro's acting crazy. Anyways, yeah, so this is all done. So I just have one more of these I have to make. This one here, and then I got to reverse all my cam to do these two, and then I have a third piece of material coming. I thought I had the right material, but apparently I didn't. Yay. So I'm going to get busy to that, and I'll be back when I got some more stuff to talk about, I think. Right, Pops? Roadhouse. Alrighty, folks. So what I did on this adapter plate, this jig, is I drilled it the whole ways through and tapped it the whole ways through. So all I had to do to make the reverse side is flip this plate over, and I got the opposite side, and I could just bolt it right down. How about that? So I got two sides. You use the jig for the one side, for the left one, and then you flip it over to use it for the right one. Pretty cool. Alrighty guys, we got the last one cut out there. So I have one more of these I have to make, and then there'll be 3 sets altogether. I was able to get a little bit better finishes on this. I'm not sure, in the cam it's played nice for this one when I reversed it. I don't know. But anyways guys, that's about all I got for the week. I'll be here tomorrow, probably Saturday, recutting the last one and some other things. I got to start a roof rack I got to get to. Poppy's got to do some work. Tired of him standing around doing nothing. Yeah, I got to get this roof rack started for this van. I got all this aluminum 1.5 or 1.25, I think. Yeah, 1/8 inch wall. I got a ton of it here. It's a big one. It's a 12-foot roof rack. Those are 24-foot sticks. So I got to get that started. That's going to be kind of tedious, but and then I have another one right after that. So other than that, guys, that's about all I got. We will talk to you next time. All right, peace out.
So bring your A game, cause you know this party won't stop. We could never run out of time, sipping strawberry lime. You know I wanna share it with you. Bass is going boom boom.
Here is 40 inch per minute probing. It's a lot quicker, as you can see.